This short snapshot video introduces scientific referencing. What is it? Why do we do it? And how do we use it to value our science? Reference is the practice of indicating the priority of an idea, concept, or process that the author is using in his or her current argument. It's an essential scientific behaviour. We know what we know in science because scientists have applied critical thinking and scientific method before us. In this sense, the priority refers to who had the idea first or who developed the concept or process that the author is using. Referencing is an art for two reasons. It's an aesthetically pleasing expression of prior work that is relevant to one's own argument. You can see in this paragraph there are 5 references. Each refers to a particular state, and it's quite readable while it still refers to 5 different pieces of work. It's also a form of expression, an art in terms of a form of expression. The beauty of that form of expression increases with practice. Referencing can definitely get ugly, so learning to do it well is an art. It's certainly the art of acknowledging the work of fellow scientists, both current and historical. In science, we truly are standing on the shoulders of giants like these. Discipline refers to training to act in accordance with rules. So what are the rules of referencing? Basically, if a statement is not something that can be accepted based on anyone's uncontested direct experience, it may need a reference. If someone has observed, described, tested, expressed as a hypothesis, or collected the data that the author is drawing on for support, then it requires a reference. The bottom line is that very little of anyone's science is original, and scientific progress would not be possible if science were not a cumulative process. So learning to reference is an art that takes practice to master, and only discipline will lead to the mastery of referencing. At its heart, referencing is organised and it's systematic. If we keep that in mind, then we'll be able to become expert referencers. So why is referencing so important to science? Referencing makes scientific writing into written science. By associating your work, your experience, and your words describing your science with work that's authored by other scientists in the same discipline. So it associates you with the broader scientific field. It demonstrates that you have investigated what is known and are pursuing something that is currently in need of scientific evaluation. It allows you to develop and acknowledge a knowledge gap that you're trying to address. It also validates your work with regard to relevant published work on a similar concept or problem. Validation is about being accepted in the scientific community. If your science doesn't reference the seminal papers or the seminal works in your discipline, then people don't have the confidence that your science is of value and is valid. So why is referencing so important to scientists? This may sound like a sarcastic comment, but it's the reality. Science is not a commodity, though it may lead to commercial products. Science in itself is not a consumable good with a market value. So why do scientists do science? Is it for fun? Not really, it's because they can. So what is its value? The value of science is measured by the value of a scientist's work. How do we evaluate that science? How do we put some sort of value on it? We use 2 different metrics. One is about how much scientific product is actually produced, and the other is how much that scientific product is in demand. And we use those 2 things to develop a citation index or a scoring system. And it ranks or evaluates scientists to give credit where credit is due. So we said that citation indexes work on how much product is produced and how much that product is in demand, or its level of use. References are the currency of scientific writing. So going back to those 2 dot points at the beginning of this slide, how much product is produced is the number of publications that a scientist has. How much that product is in demand, or its level of use, is how much that publication is cited or used by other scientists. Citation indices are generated by publication databases and are published in a variety of fora. Google Scholar uses one, and Scopus probably uses the most widely used in science. The academic search engines track the scientific research and review them based on the publications by individual authors. Let's take a closer look. This curve is from the paper that developed something called an H-index, and an H-index is probably the most widely used metric for the valuation of scientists. It plots the number of citations that each publication of a particular author has generated, so how many times it's been used by other authors, by the number of papers that that scientist has produced. So if we look down at the bottom end of this curve, this is a pretty standard curve for most scientists. There's a few papers with a large number of citations. As the number of papers increases, the number of citations for those papers tend to decrease. So there'll always be a few papers up this end of the tail that don't have a lot of citations. There's a point at which this curve intersects with the diagonal. And at that point, we have something called the H-index. So at this point is the paper above which there are a minimum number of citations. The best way to look at that is in a table. So this is a table that looks at a scientist with an H-index of 4. An H-index of 4 means that that scientist has 4 publications that they authored that have a minimum number of citations of 4. Hirsch, who developed the H-index in 2015, had an H-index of 61. That means that of the 292 published articles that he has in Google Scholar, 61 of them have been cited at least 61 times. So this metric starts to account not just for the number of publications that a scientist has generated, but also the number of times that that work is used by other authors. So it's used to rank and evaluate scientists, and you'll quite often see in scientists' websites that they'll cite an H-index. So citation metrics are generated automatically by search engines. They go up or down depending on how frequently someone's science is used in other scientific publications. They give a numerical value to scientists and their published work. The two most important are the H-index, generated by the method of Hirsch, which gives an idea of a researcher productivity. The other important citation metric is the impact factor for publications. Impact factor values journals by how many times the papers in that journal are cited in other places. So referencing at its heart is about paying your scientific dues. It's important that we learn how, when, where, and why to reference.